Analytical techniques for investigation. Modern chemical methods and measuring techniques can be used for archaeometric purposes. Some analytical techniques have been investigated with exemplification for different Romanian artifacts. Methods and apparatus. Thermal analysis presented in the following lecture helped in the characterization of pottery in order to conclude about the chemical and phase composition, and it was recorded with a Metaller 4000 TA, TG50 analyzer system at a rate of 10 degrees Celsius -1 in a static air atmosphere, Perkin-Elmer thermoanalyzer TGS2, and DTA 1700 at a rate of 10 degrees Celsius -1. A sample, 15 mg, of finely ground stones were subjected to analysis in a PT plate at a temperature range of 35 to 1000 Oc, 10 degrees Celsius -1. This concluded that the archaeological pottery was fired at relatively high temperatures. Energy dispersive X-ray fluorescence, EDXRF analyses were performed within PW4025 apparatus, type Minipol P analytical, with a C-pin detector and an RH tube with an acceleration voltage of 30 kV. Due to varying surface structures and inhomogeneities in the surface composition of the samples, the analyses are usually performed on both sides of the objects and a mean value is calculated, when the analysis must be completely non-destructive. When possible, the sample is powdered, so a representative homogeneous sample can be obtained. An XRF is known as the first powerful, commercial, fast, non-destructive, and relatively accurate technique for qualitative as well as semi-quantitative chemical analysis. Inductively coupled plasma, atomic emission spectrometry, ICP-ICE was used to quantify minor and trace elements. Detection limit for major elements is under the ppm level and the analytical precision calculated from replicate analysis is plus or minus 1%. For the ICP-ICE measurements, usually with varying equipments, the samples are finely powdered in an agate mortar and then mineralized with a microwave-assisted digestion oven with the use of high-pressure closed Teflon PFA vessels, with a mixture of 5 ml HF 40% and 5 ml HNO3 65%, and pressure and temperature control. Multi-element matrix match standards were used for the quantitative determinations. X-ray diffraction, XRD patterns were recorded on a drawn UM1 diffractometer, operating at 32 kV and 25 mA, using Co-K alpha radiation, 1.79021 A ring, with an iron filter. The diffractometer is connected to the PC, so the collected data can be analyzed and interpreted using either the dedicated program or other specific data analysis software. Fourier transform IR spectroscopy, FTIR standard spectra were collected by using a Perkin-Elmer Spectrum GX spectrometer, for a range of 400 to 4000 scans and a spectral resolution of 4 cm -1. It was possible to use the drift accessory with a powdered pure substance, thereby allowing for a better and easier analysis. The Raman spectroscopy analysis performed with Raman spectra has been recorded with a first guard Raman apparatus, base spec with two wavelengths, 1064 and 785 nanometers. The Raman system includes a superhead optic fiber for non-contact measurements, with a 50 times long working distance, LWD visible Olympus lens. The spectral data were processed with a software application dedicated to the file generation of Raman spectra. The spectral resolution was 3 cm -1. All the spectra were recorded in the 200 to 3400 cm -1 domain.